Good evening all. Today we are honored to introduce Professor J. Baskaradas, a distinguished researcher and academician with extensive expertise in radar engineering, remote sensing and ionospheric studies. Currently serving as an associate professor at SASTRA Deemed University. Professor Baskaradas lead cutting-edge research in RF system, microwave communication and electromagnetic compatibility. With a PhD degree in physics from Nagpur University, his research has significantly contributed to the development of digital ionosomes radar system, ionospheric studies, and atmospheric sensing technologies. He has collaborated extensively with prestigious international institutions, including the International Center for Theoretical Physics, Italy, and the Institute National Geophysical Volcanology, Rome, where he has held multiple research fellowships and postdoctoral positions. Professor Baskaradas has been recognized for his innovative work, winning prestigious awards such as IDX4 Challenge and Dare to Dream 2.0 Challenge for groundbreaking advancement in atmospheric visibility forecasting and radar signal classifications. His current projects, funded by leading agencies like DRDO and the Ministry of Defense India, focus on cutting-edge technologies including intercept receivers, AI-driven atmospheric predictions, and airborne geophysical platforms. With over 2 decades of experience in research, teaching, and innovation, Professor Baskaradas has contributed to 2 patents, book chapters, and numerous high-impact publications in international journals. He has also played a vital role in Antarctic research expeditions, working on advanced radar system for ice penetration and geomagnetic studies. His multifaceted experience and passion for technological advancement and dedication to mentoring the next generation of engineers and scientists make him pioneering research in his field. We are glad to have you with us, sir, today. Today, the talk series will be led by Shreevatsh, a PhD scholar under Dr. Rajkumar at SASTRA Deemed University. He holds his bachelor's in geography, tourism, and travel management from Madras Christian College and his master's in applied geography from the University of Madras. His passion on earth science and geospatial technology led him to pursue PhD in remote sensing and GIS, specializing in the spatio-temporal analysis of mangrove forest dynamics, driven system and ecosystem service in Muthupat mangrove forest. His research utilizes satellite data and GIS to study environmental changes, carbon sequestration potential, and future projection. He is also a former Guinness World Recorder, having a set to record most Rubik cubes solved while bicycling by solving 751 cubes in 7 hours 2 minutes and surpassing the previous record of 111 cubes is 2 hours 3 minutes. Now, I invite Shreevatsh to take the stage and lead us in an engaging conversation with Professor James Baskaradas.
Yes, so I welcome you all to the third edition of SciXchange. So, without further ado, sir, with your permission, can I serve you comments?
Please.
Yes, sir. Right. So, we've heard people traveling across countries, doing the research works, but then sir over here has traveled across continents, right? He's gone to Antarctica, so we have a wide range of stories from him. So let's start off with your interest in science and technology, sir. Can you tell us how it all started?
Say, interest in science and technology, it started when I completed my master's. You want to know how I started my PhD? Roughly.
Yes, sir. Yeah.
Okay. You're coming for that. Okay. It's an accident. I don't know. You want to call it? It's a destiny. I don't know how to classify that. After my masters, I went for my Air Force interview to Varanasi, and I was traveling back to Chennai. I was not selected there, so I was traveling back to Chennai. While coming back, my sister was married that time and she was in Nagpur. So I took a break journey. After coming back to Thanjavur, I was supposed to join St. Philomena's in Mysore for my MPhil and PhD combined. That time, it was in 1994. And so I was thinking about that. That was in X-ray crystallography and things of those kind. My interest right from beginning was on radio, not on radar. That time I was knowing only radio. So wireless, radio, those kind of things I was interested, plus electronics, which I got from my bachelor's degree, campus, I can say, St. Joseph's, Trichy. There, while coming back, this break journey, what happened was, I was there in my sister's house. We came back, and I was supposed to get my train back. The train got cancelled. That was the trigger point for me. So 2 days. The next ticket for me was on. I had to stay back in Nagpur for another 2 days. My sister said, "Okay, what you're doing? You're sitting in the mine." It was a coal mines around 40 kilometers from Nagpur, and when I 2 days, what I'm going to do, sitting around only the dumpers and dozers moving around. So I said I'll just visit the campus since I was looking for something, and that's how it started. I went to the campus, met my guide. Roughly, I think in 1994, February 28th, I started my first day on PhD. Almost 31 years now. That's how it started.
So, could you please elaborate more on your PhD journey, sir? How was your supervisor's way of guiding you?
Okay.
Yeah.
He's a real taskmaster. In the sense, first thing when I entered, he said he had around 35 years of experience, almost 6 or 7 years to retirement. And he has signed 8 PhD theses in that career time. And he said nobody were able to continue. Out of 9, 8 or 9, one guy was from Jordan. And other than that, nobody, all Indians only, but only 8 students. Around 20 or 25 students, they left halfway and ran away. He elaborated this and told me, asked me whether I want to join him. I did not realize what he was trying to tell me, and I said, okay, I'll continue. I have decided to take up something, and he is the one who stimulated me on the other way around, because he did studies in plasma, inside the laboratory conditions where everything is controlled. When I was talking to him about radio, he said, see, radio, radar, all those things are jargons which people use, fine, but will you be interested in exploring or using the radio to explore the plasma, which you will not see? I was thinking maybe something in the lab. Then only he elaborated on the ionosphere, and he said around 400 kilometers plasma will be moving around, so you have to detect. That's a system we are going to build, and he had enough experience, and that time he was one of the board member of Meltron, that Maharashtra Electronics. So, and the director of radio science division of National Physical Laboratory, she was very supportive in the research, and we started. First 6 months. Now, before that, I want to tell. Okay, I can tell this. First 6 months, it was almost every week I have to give a presentation. I got the title after 1 year. First 6 months, every week, only presentations. The topic of my interest. He says, you talk about whatever you want. He'll be sitting and listening, and around 12 or 13 electronic students and other research scholars of the lab, we were sitting and doing. After that, slowly got what I'm up to or what I'm interested in, and they started suggesting me some titles, and we got it finalized after 1 year. This is how it started. So, and in the next 6 months, he had a passion for radio, and he showed me his collection, almost around 100 years of radio he had collected. Still, it's there in Nagpur University campus. It's his personal collection which he gifted to the campus, and he bought around 2 wagons, train wagons of Second World War scrap. So it was transferred from Gujarat, it reached Nagpur, and we 4 research scholars with around 10 electronics, MSc electronics students, to almost 27 racks we were cleaning and arranging. So we used to go in the morning, change our clothes, okay, start dusting off all the Second World War scraps. One thing, interesting thing was, he used to come in between the classes. Whatever we are cleaning, he used to pick up that and say, okay, do you know how it works, what it is? Around 15-20 minutes, most of the things were radar display, aircraft displays, aircraft radars, all Second World War. And you know the robustness, all vacuum tube based systems. That's how we were trained in the beginning. And in that period, what happened was the oscilloscope. That I still remember that. I was new to this research, and I was not expecting the kind of experience what I wanted. the oscilloscope one channel was not working. So as usual, I went to him and I said, "Sir, channel oscilloscope is not working. It has to be repaired." He said, "Okay, repair it." Then I said, "I don't know what it is. I mean, I can only use it." Then he said, "Open it. We don't have any technician here. You are supposed to open." And he showed me one cupboard. The components are here. Replace it and get it done. Believe me, it took me another 6 months. The first year, I'm saying, to understand how the oscilloscope worked right from the scratch. And I still remember I have some problems here. Around minus 1500 volts I touched. And we had some issues on that, but he was not bothered at all. He said, "Okay, you carry on. It's part and parcel. You have to move forward." And that's how it is. I was trained like that. And unfortunately, when I came here, one guy came and asked me, "You wanted to join a PhD with me?" And he said, "Okay, when I'll finish?" The first thing was, "Will I be able to finish within 3 years?" I think most of you will be in that line. Please, I don't want to advise you, but it's not the way you should do research. It is a real task. I know. I mean, the challenges are very high. And I had the permission to have a hammock in my lab, and I used to sleep there. That's how we did in the beginning days. And one more thing is, we never had resources. And I did not have any project fellowship. We had to give guest lectures in the nearby colleges as well as in the campus, and we were getting that money and we were surviving. Only for components, my professor made the arrangements. And we had an old radar, Second World War radar again. It was built in 1969 and I was using it in 1995. We had to rework on that. That's how I started. Re-engineering that and completely converting the vacuum tube based system into a digital system. So this is the way we worked. And in the same time, when I used to go and ask for components, he used to give me transistors, replacement components. I used to connect, literally solder things, and it never worked. And he used to tell me, "Okay, did you check before soldering?" He used to give me defective components. He has a special box for that. So I was literally taskmaster, means real task. So that's how, even if you come to my lab now and when we start working, the first thing is, whenever, even if it's a new pack, new component, if it's possible, I'll try to check whether it is working or not, even if it's a new pack which you're opening. So that's how I was trained.
It's a very interesting way to learn in a very intuitive manner. So, radio frequencies and radar system designs. So that was the exact field which you were working on and still currently working on. We have research scholars and faculty members coming from other departments as well, sir. So could you please explain that field in a layman's term and how does it benefit the society at large?
Okay, radar engineering, yes. Whenever there was a war, radar people, we used to get a lot of fund. That's how it is. If you look at the radar history and development since since the Second World War, there was not much funding pumped into the radar research. If at all, if someone is getting, it will be only for the defense sector. And we did not have those kind of satellites which we have now, where we are using it for commercial and civilian purpose. So till 1960s, 1970s, the radar means it is defense, airlines, air force. But to put it in a layman's language, what we do with the radar is we use radio signals to characterize whatever targets we have. That is, it can be a plasma. I did it and study the plasmas, but it can be any metal reflector. And it can be even objects, synthetic aperture radars. Now we are doing a global imaging of the surface imaging. Specifically in the field of agriculture and urban development, people are using extensively. Now with the automobile industry, there are radars which is applied for the collision avoidance. Specifically collision avoidance is one thing. But the radar development is getting a lot of funding now because of autonomous vehicles. But when I was doing my research, funding never came for radar. So what we used to do is, not only me, this I learned from others. We study electronics and communication, telecommunication specifically. What are the technologies they are building? Because there were a lot of funding from the mobile industry for building mobile networks, telecommunications, specifically data in terms of mobile as well as fixed wireless systems. There, whatever innovations coming up on that side, we used to pick up, apply it for radar. Since we play with the same radio systems, we pick up from that and we apply here and get it going. But now in the last 10 years, I can see a lot of investments coming for even civilian radars, where civil applications, specifically on ground penetrating radars, there are a lot of scopes. And airborne synthetic aperture radars, that's also finding a lot of scope here.
Yes, sir. Shortly after your PhD, you have traveled to Italy, sir. So, can you talk about your life when you were at Italy? What were the cultural experiences you faced over there, your favorite cuisines, and so?
Okay, cultural impact already I had. I experienced it in India itself. When I went to Nagpur, people used to talk to me in Marathi, and I know only Tamil and English. Nothing. It's a real tough time. And then I started learning Hindi, and little bit of Hindi and Marathi I was surviving. And the food is completely different. So this was not making much impact when I went to Italy first time. That was in 1997 during my PhD event. After that, I was spending some 11 months' time in 2000. Then I went for my postdoc. So there, culturally, working culture, it is something different, which I miss also. I have to be honest on that. You will be given a task. You organize your time. Nobody will come and ask you what you did and whether you are progressing. This, nothing. Your task is this. This is the timeline. Finish it. If you need something, it's our responsibility to ask. That is one good thing that happened there for me. And here at Nagpur, I used to stay there in the lab only. My professor in Italy, he used to call me a slave. For 6 years, almost, I don't think spending any time, maybe all of us, not only me. The campus culture itself is like that. We used to stay in the lab. We never felt the difference. One thing, a sad thing, for the first time I heard the word stress being used only in Italy, not in India. And nowadays everybody is talking about stress, tension, and here we were working almost 7 days a week. Fortunately, we were not married that time, so only lab. That's the only responsibility we had doing our work. From all branches of engineering, not engineering, and science specifically, right from physics, chemistry, psychology, we had all campus students. We used to meet every evening, around 10 o'clock or 10:30 in the evening, then around 12:30 in the evening. There were groups. We used to sit and talk for 10-15 minutes. That's a break time. And 1:32 we go to the hostel. That's how it is. In Italy, the story is completely different. It is 5 days a week. Sixth day, I did not have any permission to come to the campus. Well, my professor completely rejected it. Saturday, Sunday, you do something outside, not inside the lab. And if you're entering the lab, if you're working, enter or else get lost. That's something which made us more efficient, and we were, not only me, and we had a very good team culture. We used to do projects at, say, 1.5, 2 million euros projects, around 6 or 7 people managing the project. Most of the time we were ahead of time. When we used to run the show, it's well organized, completely streamlined system. That was I'm talking 2004, 2005, during that time. Lot of liberty, but with the responsibility. That is something which we should not miss. Nobody missed out. I mean, if you look at the working hours for me, 40 hours a week that time. I can spend the way I want. I finish everything in 3 days or 4 days. 2 days I will not come to the lab. But trust me, voluntarily everybody was working for more than 30, 40 hours extra every month. It's not that we were not enjoying or we were not doing. Apart from Saturday, Sunday, the remaining days we were working. That is one thing which is bringing out the efficiency of individuals that were well organized and well planned. All self organized, I should say. And that's how it is. As far as food is concerned, yes, first 6 months I could not finish the first course itself of food. Because in Italy, we have the first course, second course, then the salads, then ice cream and coffee. I mean, it goes on. They used to cook for, say, within half an hour or 1 hour, they finish cooking, but they used to eat for 3 hours. I mean, that's how it is. In India, the other way around. We used to cook for 4 hours and finish eating in 5, 10 minutes, 20 minutes. Food is really good, Italian food, and honestly, you will not recognize me if you see my old photographs. After going there only, I put on a lot of weight.
Since you spent a lot of time in Italy, I'm sure you've learned Italian, right, sir? How fluent is it?
See, in the last 10 years, I lost touch, but I was talking and writing there.
So, if I ask you a question in Italian, would you be able to answer?
And try.
I mean, come ti senti oggi?
Okay.
It means how are you feeling today?
Come ti senti oggi?
Yeah.
Yes. Sento bene.
I don't know Google Translate, so you have to tell me.
I'm fine. I mean, I feel better.
Wonderful, sir. Right. So, in Italy only, the inception of the Antarctic voyage began, if I'm not mistaken, right, sir?
Yes.
So, can you please tell me about your Antarctic voyage? Like, when you traveled in the shipping vessel, when you went over there, what type of research did you conduct? Just give us a brief overview of it.
See, actually, I started in Italy in 2001 as a postdoc. And we started building radars. That time, being a non-Italian and non-European, I did not get a chance to move above certain level. I got my permanent residence sometime in 2007-8. After that, I could get. We started building whatever radar I was building in India, in Nagpur University. That gave me a lot of exposure and experience I got here in India. Literally, I can say whatever experience I had at Nagpur, I was riding for almost 3-4 years using that experience. And we built radars for ionospheric studies and advanced radar version. And we had the first opportunity to do research on developing a radar to detect the first deepest point in Antarctica. Because normally, if you look at the Antarctic terrain, you have around 2.5 to 3 kilometers of ice thickness on an average over the bedrock. EPICA was one of the leading projects done by Professor Tabako. I mean, he's late, he's no more now. He's a geologist and he was leading the project. And on the instrumentation side, my institute was associated with him. So we started building specifically ground penetrating radars. And we did some test flights in Canada, Greenland. And after successful completion of the test flights, we decided to take it to Antarctica. That's advanced version of the radar. But the previous version of the radar was at 60 megahertz, means a low frequency radar where we study the stratification of Antarctic ice. And we were given an opportunity to do a test flight to decide the point of drilling. So one of the biggest project which I have come across, I was not directly part of it. It's an EPICA project done by around 6 or 7 countries, where they used to get around 25 to 27 million euro every year for running that project. The objective is to study the climate, paleoclimate I can say. You drill a ice carrot, take the ice out and try to understand the type of aerosols that were present during, say, roughly, even January there was news on this, on the same site where we identified. They have drilled around 2.5 kilometers of ice. And now they have a history of temperature for almost 1.5 million years in the past. And our radar was the one which was helping them to decide this is the point for drilling. So we did the test flights and we did a survey. I mean, I was involved in a couple of surveys, but it's a survey done for around 8 or 9 years, more than 9 years, by 6 different countries. They were trying to help us, covering more than 3,000 square kilometers of Antarctica ice. And the database even still reveals you have a lot of water flow at 2 point. We were trying to identify the rivers. The best part was people strongly believed the Antarctica ice around, due to the pressure of the ice, around 3 or 4 kilometers thickness of ice, and geothermal temperature, the mass balance, the weight of the pressure and the geothermal heat, which it melted the water, and there were lakes. In our flight itself, we identified more than 200 lakes, different lakes around. We catalogued it, and one of the deepest point, Aurora Trench, where we found around a lake 4.7 kilometers below the ice. So that's the deepest point which we could get there. And this research had gained a lot of interest, trying to drill the carrot, that is, drill a carrot in and take the ice and study the temperature at different era, the aerosols present, both man-made as well as natural aerosols, and the air pockets. And they were trying to take samples. Only the problem was how to take a sample without contamination. The moment you probe in, Russians did a good job in trying to drill around, there is something known as a Vostok Lake. They drilled, they reached up to around 3.5 kilometers, and the whole international community, they stopped them, literally forced them to stop, saying, okay, you cannot drill now, tell us how we are going to take a sample, water sample, without contamination. They did not have any research. The whole international research community did not have any idea about how to sample it. They started drilling. In the whole exercise, they developed a very good drilling mechanism, because you have to drill when the temperature is around minus 55, minus 60 degrees. With the wind chill, it reaches even 60 plus, minus 60 plus. So that mechanism was well developed. So they were drilling, taking the ice, all the samples done, both chemistry, chemical studies they do, and the whole exercise was lost just like that. That is, one research group, what they said is, Antarctic ice is floating and there is no isolated water below. Almost more than $1 billion spent on this research went away. What we got back was a drilling technology, cold region drilling technology, very good cold region electronic, but people are still, they are continuing. It's not that it's lost, I cannot say that. They are continuing to do. Even British Antarctic Survey last January, they claimed they have drilled up to 2.5 kilometers successfully, and they have catalogued it. And one good result from our side, what we got is, we demonstrated without taking a carrot, we can do the temperature profile using only the radar kind of funding. But some groups are still continuing to work on that. So this is how it is. I cannot say it is all a success story, but even when there are hiccups in between, but you can always come out. This is one part. And the first thing, when we went to Antarctica, the first exercise it was very, I'm not. We crossed 72 degrees. It was not in a ship. We were flying a C-130 Hercules. Okay. So it's a very old aircraft. We were asked to take off in Christchurch. We were flying from Christchurch. We had to fly to the Italian base. So we all dressed. We were forced to dress the full complete minus 40 degrees suits. Because if something happens, they said we'll drop you on the ice and we'll come back, or we'll do something. You have to jump out, and that's a regular exercise there. We got in, and just before takeoff, the pilot announced, "Okay, we have some problem with one of the engines." So we came out of the runway. We went up to the runway. That time they realized it's a New Zealand Air Force aircraft. It's not a regular one, and they were waiting for the engine replacement to come from US. So 3 days we had extra time in Christchurch. We were going around Christchurch visiting, and then after we reached, that time I think some of you might remember the tragedy. French helicopter was crashed, and first exercise our team, when we went to Antarctica, what we did was we received the 4 bodies of the dead researchers, and we kept them with us for a couple of days and sent them out. It was a very tragic experience. First time, with all expectation, you reach Antarctica, and within 5 minutes they knock your door and say, "Okay, come, we have to receive the bodies." Yes. So this is what life is. When you have to accept that, we were disappointed, to be honest, and but later on we realized we did something good. At least we were there to receive them and give them the last respects and send them home. All youngsters. Pilot was around 28 years old, and it was a very tragic helicopter crash. After that, we were down for a couple of days, and then we started moving. Only pastime in Antarctica, before you ask, I'll tell you that.
Yes, sir.
The people from biology, and they used to do specimen studies, their chemistry, and they take seawater samples, and they used to do fishing. So whenever the temperature, when the climate is bad, we cannot fly helicopter as well as aircraft. So we'll be free. They used to take us for fishing. So that is one event we used to enjoy, the break. But sitting there doing nothing by holding the rod for 2 hours, it was fun, and it was completely quiet. We were hardly 15-20 of us there during the initial period. And you go out and see, everywhere it will be white, and you travel another 100 kilometers by helicopter, land there, it will look the same. There is no reference at all. Wherever you move, the place is like that. That's how we were living there for some time. And when we reached a spot where the penguins were there, we saw a team of researchers. They were spending almost, for the last 3 months, they were sitting there in a tent. American researchers. That time we felt, okay, we are in a better half than them. And we brought them in, and that's how we live. Hardly in the interior bases. I was talking about the coastal base. When you go interior, it will be, at any point in time, the total strength will be 40 or 50 maximum, including the mechanics, the technicians, the cook, the doctor, 40 or 50 people in an area of around, say, 2,000 square kilometers. That's the way we are in.
Yeah, it seems like your entire life story is just like radio waves going up and down, sir. So, right, right, sir. So let's move on to your awards, sir. Your awards and recognitions in IDEX 4 and Dare to Dream 2.0. Could you tell us what those awards are exactly to the people who don't know, and for what work did the recognition come under?
Now, IDEX is the Defense Innovation Challenges by the Indian Defense Ministry. Myself, Dr. Venkatnathan, Dr. Sriram, and Dr. Ilakya, 4 of us were participating in that. It's a teamwork where every year we get a call on that. And we won the IDEX 4. And there also, I want to highlight this. 4 of us in 4 different places, we were doing everything, and we just scrapped things and we created a presentation. We went for the presentation, we were sitting in the Typhacor room there with the presentation. I think we had to wait the whole day. They asked us to come around 9. We started a presentation around 4 or 4:30. Trust me, that's the whole time 4 of us were sitting together. It gave us a lot of time to interact. Literally, we formulated the project there only, reiterated. And when there was a presentation and when we were defending the questions, there was a very good harmony in the whole team where we were able to seamlessly answer. If the question is on technological part, someone will answer without any pointers being placed. If it's on the basic geophysics, one will answer. If it's on machine learning, that way it was very smooth ride for us. But we were cursing the whole day and sitting in Air Force for the whole day, but at the end we got it. And Dare to Dream is another experience. I got to know about this just 3 or 4 days before the deadline. I had no idea about what I'm going to do. And it's a prestigious award, and that was the second edition of the award. First edition we were not knowing at all. Second one we got to know, and only 4 days or 3 days. That's a very stringent timeline. And in 2008, I did one work in Italy. I presented that to my professor there. Literally, he discarded. He said, okay, we have other priorities, other things to do, but I'm not saying no to it. Let us keep it for some other day. So that's the work I presented here. So that's the only thing I had. I reworked on that in those 2 or 3 days. And it came to me, and that's how I got the Dare to Dream Award. Why I'm saying this is, normally while doing research, we do a lot of work, we'll not get the results. Most of the time, we'll be running out of results or we don't get the results what we expect. First of all, you should not expect any result. You should be doing research, whatever comes the way, try to understand. But this particular aspect of expecting result, I would like to tell you that better avoid that. Predicted results. That is not the way I work. So what we did was we started this in 2008. We did, just I left it there. After coming here, we reworked and got it done. So whatever pending work, today you might say, okay, this is not the way I want to work, or this is not giving me the result I want. Please don't discard that. Shelf it. Some other day it will come handy. Maybe today, with the limited knowledge what we have, we may not be able to interpret that, but some of your juniors who might come and use that might interpret in a different way. So whatever work you're doing, don't try to just leave it off. Shelf it. Keep it there. You don't have to look at it every day, but just document it and keep it. It can come handy.
Moving on to your startup company, sir. Can you shed some light on it? What is it you exactly do on that?
No, it's a Dare to Dream Award. We were never thinking about startup companies at all, to be honest. The Dare to Dream Award, after winning the award, when we came back, DRDO called and said, okay, this project is one of the pioneer project which we wanted to take it forward. So they wanted to fund it. That's how it started, and we ended up having the startup company. It's the Dare to Dream Award converted into a product. Still we are working on that. Myself, Dr. Shriram, Dr. Raju, 3 of us are there. And we are trying to build an intercept receiver. This is also unfortunate. I mean, India is importing that receiver. Approximate cost of that receiver is around 12 crores. The fund we received for building something similar, that's what they are expecting, is 57 lakhs. So, this is how it is. This is how we have to face this. No point in complaining about this. So we have worked out a solution for this, and what we can do, we are building a demonstrator. Right from beginning, we are telling that, and we are building a demonstrator. So the startup is still starting. I mean, we are just pushing forward to kickstart. But we have come up to a good level. The amount of things we learned in the last 2 years to create this product, yes, it's
So let's move on. After Italy, sir, you spent a long stint over there, and in 2014, you were back to home base, Shastra. Can you walk us through with the transition, sir?
no, I don't want to walk myself. Uh, say, okay, it was the family requirements, so I had to come back. We were contemplating on that. Fortunately, my wife and myself, we sat down and we spoke. My son was not that much in favor, but still, I mean, he had no other option to follow us. So, because of my family, my mother, I had to come back. So,
Okay, sir. Right. So, given all the experiences you have learned in Italy, previously in Nagpur University as well, sir, a very intuitive way of learning as well as setting targets and goals on your own. Um, how do you impart those to your students and research scholars in general? Like, what is the methodology you implement to get work things done, or how do you make them grow as research
say,
scholars?
honestly speaking, I just provide them, facilitate them with the facilities. That's all. The work they formulate, I try to follow the same. At least I cannot ask them. I tried asking them to give presentations every week, like my guide did, but I don't think that works out here. So I used to have a discussion at least once a week, and informal. It's not necessary. It's a formal discussion. I don't want to impose things. After some time, they themselves will fall in line. I mean, they have to do something. They cannot just keep on escaping. I give them all the facilities. Whatever. One thing I always insist is I will not give you a problem if I know the solution. So if they come to me, I have nothing. I mean, I'll say I will follow you. You take me out. This is the problem statement we define together. So that is, I was very particular. If I know the answer to a problem statement, that will not go as a title for my student. So I'm very particular on that, and push them. They'll take me. I mean, that's what fortunately that's happening. And other than that, we have discussions. It's not just the result. Even in one of the meetings, first meetings, they were asking the research DC, I think, first student. That time I was very fresh and I came to India, and the challenge was we were building an antenna for low frequency radar, which we were supposed to fly it on the helicopter. And we had arranged for the testing in Antarctica through the Italian because they were not able to transfer the money here. So the transportation, the funding and all, they'll take care. Only thing we have to give the design to them. And I did not have any fund directly here. So they bought the software and they transferred the license to our institute here, and that's how I started. And we did the design, and when on one of the DC meetings they said, okay, if the design fails, what you'll do? I said, I'll present it as if this is one of the result. I was so ignorant, but see, I have to confess, teaching, I was not expecting. I'm going to do the teaching. When since I, after PhD, I went out and I was staying there. I never had the idea of coming back. As I started my Nagpur journey, the same way I came back. And after coming back, so it was a real shock for me. Okay, how I'm going to adjust and adapt. Actually, my family members, they adapted faster than me. Only I was thinking of them and I'm not adapting. That's a bit of struggle I had. And this particular problem statements, when we are talking about problem statements, the connections that we get, it's most of the time it is personal life also is going to influence. So I used to talk to my students about their personal touch will be there. Not in public, maybe we'll go to KC or somewhere, move around and talk inside the campus. There I will give some pep talks saying, okay, these are the things which you can do, which you cannot do, but we have to move forward just to get the result. Well, I tried, and the same answer I gave in the DC meeting also. If the result is a failure, I'll present a failure. That time they opposed in the beginning, and they said all the best. I said okay, and they continued.
So, if I'm not mistaken, the teaching career of yours, along with research, started here at Shastra, right? So, like in a
Yes,
full-time
yes,
mode.
yes.
So, can you tell me about your favorite moments of teaching?
Favorite?
Moments during your teaching career.
Okay, during the teaching, first time, the first class, I mean, initial period, yes, I had to prepare 6 or 7 hours for talking for 1 hour, and that's how I started. Now it is come down to 2-3 hours or 2 hours is enough. Since I'm teaching the same subjects, I mean, the best moments, I can point out a couple of them, but I started realizing I don't know many things. The moment some of the students very intuitive, they used to ask questions. After that 15 years of experience, there are certain things which I studied superficially. That questions tickle me in, and we used to have Friday discussions, not with the research scholars, only with the BTech students in the microwave lab, and we started around 3 to 5 Friday. That time, that slot I had the free slot. That moment I was enjoying. Later on, the place where I sit, that laboratory was, we had the access to that even after 5. So the students, they used to come and we have common discussions on the topics. So that is the moment where I started realizing highest form of research, maybe, not maybe, I mean, I have to accept now. It is if you can explain whatever complex theory or whatever complex subject to someone at a fundamental level, very basic level, and where you can interpret equation, not just deriving equations, where you can interpret equation, that is, I learned here with the students. That is the moment which is something I have to accept.
So 1 decade here at Shastra, sir. So you've seen a lot of changes which has undergone in our institute. So can you tell us, on your perspective, how Shastra has grown during that stint? In your own words.
How Shastra has grown, I mean, I don't know whether I have the capability to judge that. And I see a lot of transformations. Apart from structures, the way in which we are working, the way in which things are getting. See, that's how it should be. It is. There are lots of ups and downs. I cannot. I mean, I can point out both positive and negative things are there, but that's how it should be, and it's. I think it's going in the right direction, which I'm comfortable with. And laboratory infrastructures. Personally, I know at SEEE, we have scaled up. We have scaled up a lot. When I came in, I had one MacBook Pro with me, a desk and a chair to sit, and I used to work there. After 3 or 4 weeks, I lost that also because of the power fluctuations here, it went off. I was not knowing the exact usage there, that plug point I was not supposed to use, so it burnt out. So they did not repair it. I had to struggle for some time. But now we have the facility with all the infrastructure where we have, it is all with UPS, no fluctuations. Except still, yesterday, this morning also I went and complained about the UPS going down. It is solved already. So that's how it is. The infrastructure, yes, it is coming up. The responses are good. If you ask for something, it is coming fast.
What do you admire about the research fraternity at Shastra, sir? Like, is there anything you would like to tell us?
I think I've told enough. And this is some good initiative which We used to do in Nagpur University campus, we used to do this. Not exactly this way, but it was an informal, but with a lot of, all the professors will be there. We have discussions across the departments. Common discussions, even couple of times we had science and religion. That's a one-day workshop on that. There are a lot of things, but that is something which I'm saying. Before, it was only, I was knowing only SEEE students, and now slowly it is, I can see I know a lot of faces here.
Given your great deal of experiences you've experienced, like in abroad, and not only in Italy, but other countries as well, which you have visited, I'm sure of. This is kind of a question which can be useful for all research scholars if they want to, let's say, elevate their research career after their PhD, say in a European nation, sir. What are the prospects which are currently there, and how do you think we should, as research scholars, approach to seize those opportunities?
See, opportunities are there, but always the struggle is there. Even now, I hear people saying the European Union is closing in, and there is no facility for foreigners to come in. See, this has happened to me also in 2001 when I went there. My professor had to write a lot of things to the Minister of Internal Affairs why he took me as his postdoc. Because I'm going to get the national scholarship, Italian national scholarship. Why the tax money of my people should go there? It's a standard procedure. It's not that nothing harm in that. So he had to defend certain skill set available, not available in the region. This happened when they want to convert my postdoc into a permanent position. So they had to defend and explain why they are taking me, excluding the European Union and the Italians. So the same thing they are going to face, which is fair enough. Every country does this. Better make the connections. Almost all the professors here, they have some connections outside India. So try to establish now itself, visit the labs, and a lot of student exchange programs are there. And after coming in the last 10 years itself, I have seen some of the research scholars from SEEE, they are abroad now. I'm very confident if I ask them for some support to one student, they'll connect them. So it is your interest, on your interest, you should try to make sure, maybe this is a good forum where you people will be meeting, get to know who are your ancestors, the seniors, connect with them, most of them are outside, and they know the present situation. Maybe what I'm talking is 10 years old. Last 10 years, I'm not out. I'm staying here. So the geopolitics has changed now. They are going to have problems. That is there. But how to come out, you have to connect yourself. The connections you make. And it's not that we don't have people there. And there are your seniors, not our faculties, but your seniors are there. Past 3-4 years, I get to connect people from SEEE, and they are saying, even some of the computer science fellows, they are saying, okay, they are ready to fund. They wanted to sponsor some students. They can build some projects. They are ready to send components. They want to send money. I said, no. You buy them components for them, they'll build it. So there are people. So you try to connect, and there are a lot of scholarship. European Science Foundation. I think DAD is one, Germany. DAD is there when I was doing my PhD. It's still effective. And in Sweden, the social security is good. A lot of people are there, Indians specifically. Try to identify which is the right lab for you. I'm sure you sit and talk to your professor, your guide. See, that kind of interaction should be there. When I said I told you only my guide is a taskmaster. Every Sunday we used to go out for breakfast. Not in campus. Sunday morning, because I was in the hostel, he was a bachelor. He comes, picks me up, and we go to an Indian coffee house there, and breakfast is with them always. Almost all Sundays with them. So that kind of connection you should get, and talk openly and try to connect. I think this is the only advice I have. because I will not be able to tell what exactly. The geopolitics is same in the sense it has transformed, but the constraints are same. There is not much.
Okay, sir. I think we've come near to the end of the session, and sir has hobbies like all of us, right? Farming. From Selvakumar sir, I got to know about a bit of a philosophy, and there's also one more, sir. Guitar.
That was long back.
Yes, sir. So we have a surprise for you.
I'm sorry. Say,
If I kindly request you to play one small note for us, sir. If you don't
I'll
mind.
be able to play it now. Okay, try.
It's okay, you can try your
I
best.
can ask my son to do that. It's almost 10-15 years.
No issue, sir.
No, I'm not able to hold it. Spanish. No.
It's
I'm
okay,
not
sir.
able to hold it. I miss my plucking.
Yes, sir. Yes, thank you very much for this, as well as sharing your experience as a whole. I'm sure that we've all learned quite a few about how you have faced challenges, how you overcame them, and also a glimpse on your life, especially the Antarctic voyage, which was not unheard of in you, should, sir. So thank you so much for your time. We have a small token of appreciation for your presence of here, sir. Thank you so much, sir.
What's next?
Yeah, that's it. Yes, so we come to the conclusion of the third edition of SciXchange. Thank you to all the faculty members and research scholars who have given your time to come and witness this and listen to us in your busy schedules. Yeah.
I thank all of you for joining us to the third episode of SciXchange, and I would like to thank Shreevatsh for moderating this section and making this section an engaging experience to all of us. Before we conclude, please note that the refreshments are available outside, and thank you again for your participation. We look forward to seeing you all in our next section. Thank you.